Okay, so today I would like to present LVSB, or we can call low voltage switchboard. Okay, this one is a low voltage switchboard. This one we got digital meter, and this one is a indicator light. Indicator light, the function is to alarm the operation status of the equipment and to monitor. And this one is a circuit breaker. A circuit breaker, the function is to protect low voltage circuit and mainly for energize and cutting of high current. And this one is a heater switch. Heater is to warm up the low voltage switchboard so that the low voltage switchboard always maintain the humidity. Okay, this one is a MCCB. MCCB stand for molded case circuit breaker, and this function for provide protection against overload. Okay, kWh, and this one is a kWh meter or kilowatt hour meter. This to design to measure the electrical power used over a long period of time. And this one is IDMTL. IDMTL stand for molded case circuit breaker. This provide protection against overload. And this one is analog low voltage power factor. Okay, the function for power factor is to measure the power factor of transmission system. And this one is a 8-valve relay and H-leak relay. What different is 8-valve relay for monitor power system and provide a relay operation in the event of an H-valve situation. And H-leak relay is to residual current monitor that are used to detect potential dangerous ground fault current before they can cause any hazard. And the last one is IDMTL. IDMTL stand for inverse defined minimum time lag, and the function is to tripping of the main circuit breaker when a fault or overcurrent condition is except the preset value. Okay, so that's all from activity 1. Thank you.
Hi, Assalamualaikum. My name is Aiman Fatina binti Muhammad Kamal. My matrix number is DE20094 and I will present a schematic control diagram for main incoming. Okay, so in this video, I will keep zooming on the component like that because I want the diagram to be seen in the video. Okay, so first thing first, this is how a single diagram looks like. Okay, so how to read the schematic is by knowing where is the main supply, okay, the incoming supply, I'm sorry. So here is the incoming supply. Okay, why this incoming supply is at below, not up, because I will explain in a simple diagram. Okay, this is the LVSB. Okay, here is the bus bar, and then here is the floor. Okay, so usually we'll have a ladder, okay, here where the main supply cable are have there. Okay, so the main supplier is from TNB or from my hometown, which is Sabah. The main supplier is SESB, Sabah Electric Sdn Berhad. Okay, so how do I know this? I have the opportunity to intern in a power plant, so I have some experience seeing this LVSV in real life. Okay, so in my workplace, here is not that deep. Okay, so yeah, So we move on to here. So, okay, as we see here, this is 415/240 volt. Okay, 3-phase 50 hertz AC supply. Therefore, we know the incoming supply is 415 volts, and then it will be stepped down to 240 volts, and then it is a 3-phase circuit and then 50 hertz. I think in Malaysia, usually the frequency will be 50 hertz. For some country like Japan or US, it will use like 60 hertz, if I'm not mistaken. Okay, and this is a AC supply. Okay, so how do we know which is which? I mean, which color, which is red, which is yellow, which is blue? So we can know by looking at the wire. Okay, like this actually stands for red. Okay, so this is a red. Okay, so wait, I change it to yellow. Okay, this is yellow, so this is a yellow line. So blue, blue, so this is a blue line. Okay, so E, which is stand for neutral or ground, because it's connected to ground. Okay, that's how you know which is which. Okay, so this is actually this is actually a label in the wire. Usually have a tagging there, so when it comes to maintaining some, if have some problem in the in the LVSB, we know which to look at. Okay, this is the contactor, this is also labeling. Okay, and then so when even this is one straight line, in the reality is actually not that straight line. So how do we know? Is by tagging each one. So this like have two wires, something like that. So one is this and one is this. Okay, so we move over here. Okay, this is current transformer. Okay, CT is stands for current transformer. Why have S? Because it has 3. Okay, so we know that it is 115 amps. Okay, step down to 5 amps, and it has 3 units. Okay, why it needs to be stepped down? Because we are handling an electronic component which is cannot exceed 5 amps. Okay, so the current will move to here. Okay, and then we'll go to the kilowatt hour meter. Okay, and then it will go to here. Okay, and then this is the miniature circuit breaker. Okay, after that it will go up to here. Okay, the main supply, the indicator. Okay, in my internship, we will do like weekly maintenance here. We will like make sure all the 3 bulbs light up, because if not, sometimes if the bulb is broken like that, we don't know they have supply or not. So that's why we will do a weekly maintenance to maintain the bulb. Okay, so it will go to here. Okay, here. So here is the heater. Actually, the heater is to control the humidity. Okay, so in control, okay, switch room, LVSB room, there will be aircon. The aircon is actually to control the heat. Okay, but when we have the aircon, sometimes it will be have a moisture. Okay, So when have the moisture, we don't want that, okay? Because in the electronic, it's an electronic component. So if have moisture, it will be broken. Chances for the electronic component to be broken is very high. So that's why we use heater. So by having two types, which is aircon and heater, we can control the humidity, the moisture. So we can use the LVSB longer. Okay, so the current will go here. Okay, go here. Okay, so this is actually shunt. Okay, I'm sorry, shunt trip coil. Okay, shunt trip coil. Okay, so this is stand for SCB, is stand for air circuit breaker. Okay, so this is the protective relay. So here, okay, is CL10P10. This stand for class for protective, okay, protection. I'm sorry, protection. So I have 4 because I have 4 relay. Okay, we show you over here. 1, 2, 3, 4. Okay, this is earth fault, this is overcurrent. Okay, which is this part will be explained by my group members on the diagram 3.4 and 3.5 after this. So after that, the current will go here, and then here, as you can see, is CL1. Okay, CL stands for class, and then don't have P, right? So it stands for meter. Okay, meter. So it will go here, and then go here. This is actually ammeter. Ammeter. So, but have S here. So it stands for switch data. Okay, set switch data. Then here is 150 A over 5A amps. I'm sorry. So because this is still a component, so cannot exceed 5 amps. Therefore, we'll go to here, power factor corrector. Okay, power factor corrector is actually, the function is to improve the power factor because this is a small industrial. This set is for small industrial. So sometimes we'll have like fault occur or current drop, voltage drop. So by using this, it will improve the power factor. So it will not get penalty in the bill. Okay, if doesn't have this one, so when happen like for a core, like current drop, voltage drop, so it will affect the bill. Okay, and then we'll go here. Okay, CL1. Okay, this one is meter, this also for meter, but this one is for voltmeter. Okay, so we'll go here and go to here, voltmeter, and set data switch. Okay, this is actually the same, the switch data. And then the switch data is in analog form, so we have to set it manually by one by one. Okay, and it will reach here, the bus bar, and then the indicator. So the indicator will light up, and then the current will go here. Okay, to the load. Okay, the supply will go to the main bus bar and to the load. Okay, that's how we know. So in the switch here, so we'll have this kind of light. Okay, here is for the main supply, and here is for the bus bar. Okay, I'm not draw that so perfectly. Wait, we can go here. Okay, we can go here. Okay, this is the for the TNB supply, main supply. Okay, indicator, and here for the bus bar. Okay, that's all from me. Next, my group member will continue this video. Thank you very much for your time. Assalamualaikum.
Assalamualaikum. My name is Amirul Haziq bin Jeffrey. My metric number is AE190038, and today I will talk about figure 3.4. This schematic diagram is from figure 7.3. The incoming from main bus bar will connect in the circuit breaker, that is MCCB. The circuit breaker then will connect to the ST, that is shared trip coil. After that, it will connect to the coil or contact. It has two types, that is normally open or normally closed. When it is in an open condition, this figure is in open condition. When it is in open condition, the cord is closed and it will give signal to the diagram, and it will give signal to the circuit breaker to open, and then the DAN will open. After that, it will connect to the protection, which has primary and secondary. After that, the incoming voltage from this will step down to 5 ampere from 100 ampere. After it has stepped down, it will go to the current relay. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Haniza Shaira binti Arman. My metric numbers is DE 200109. Okay, I will talk about the ELR. ELR is stand for earth leakage relay. Okay, firstly we need to know what is earth leakage. Right, earth leakage is an unintended situation in which a conductor carrying a current comes in contact with the earth or casing equipment, either directly or indirectly, it causing a current flow to the earth. Alright. It's happen when the installation failure or electric shock. Electric shock is current flow through the woman body to the ground. Alright. Okay. Earth leakage really. What is actually earth leakage really? ELR is the device used to detect the current leakage. Current leakage. No, to detect the over limit current leakage by the present value at the relay. Alright. ELR is the electronic component, so the incoming current to the relay should be 5 ampere. Alright, 5 ampere because it's electronic current, electronic device. Sorry. Alright. As we can see, this is earth phase. Sorry. Before that, I will explain the drawing, schematic drawing. Alright. Firstly, we can see this is a red phase, yellow phase, blue phase, neutral. Alright. So ELR is electronic, so we need to making a connection as a single phase. So as we can see, this is the numbering of cable, right? Numbering of cable. Okay, this one is numbering cable 2, but this is R92. So it means R is stand for red. Okay, 92 is the numbering of cable, alright? So Okay. We okay. So we can see 9 numbering cable of 9 will connect to the red face. Okay. 7 will connect with tapping to the neutral. Right. So this one is MCCB. This one is ST. ST is stand for shunt trip. Shunt trip. It stand for shunt trip. Now, okay, what is shunt trip? Shunt trip is a device that designed to switch off the circuit breaker. Okay, later we will see the working principle for ST. Alright, firstly, I will talk about the relay first. Alright, this one is ZT. ZT is stand for zero current transformer. Alright, this one is to monitoring M. Alright, okay, this one is to monitoring M to flow in the relay. Right, the connection is just a looping connection. It's just tapping. No, it's just clamp to the face, and then come to the relay. Okay, this one will tapping at the red face. This one is to monitoring M that to come in the relay. Alright. Okay. Alright. So when the overcurrent, when the ELR detect the overcurrent flow to the relay, alright. Sorry, I will use the other current. So when the overcurrent flow to the relay, in other words, when ELR detect the overcurrent, right? So ELR will energize, and then the contact will close. Okay, is detect the overcurrent, so the current will flow, and then this one become closed, and then moving to ST. Alright, ST is shunt trip, right? So shunt trip is a device used to switch off the circuit breaker. Okay, how it's work? Alright, firstly, shunt trip energize. The release shunt will active the circuit breaker mechanism, right, immediately to ensure rapid disconnection from the power source. Right. When this energized, the circuit breaker will active. So it become like this. For example, when this connect, right, this one is active. This one non-active. So when ST energized, circuit breaker will active. So this one is touching. Okay. So when MCCB will active, when MCCB active, there is no current flow to the load. Okay. Because this circuit not touching each other. Right? So no current flow to the load. So the current no current load, there is no electric shock to the consumer, to the load or to the consumer. Alright, it will save the load and consumer too. Okay, so like what I said before, ELR having a limit setting, right? So this setting will determined by the consult engineer before the LV room are built, right? Okay, so ELR, this ELR should having a preventive maintenance every 3 months. So every 3 months, the owner will hire the contractor to do the calibration. In reality, we don't say preventive maintenance. We say the calibration for relay. Okay, what happen when we do the calibration? Okay, when we do calibration, we can detect either the relay can be used, can be work well or not. So every 3 months the calibration will do. So the calibration do sorry, calibration will when we do calibration, we inject the current to the relay. If the relay trip at the setting, relay, it mean that the relay can be used, can work well. There is no can work well lah. So but if the relay not trip, when we inject current, there is no trip at the relay, we can say that the relay as a failure. Okay, fail. It cannot be used. Right. So every circuit having their own limit current. Uh, I usually I saw that 0.3 ampere, 0.5 is depending on the circuit that built in the LV room. So uh, so okay, the calculation will do the consultant engineer will do the calculation, so it will give to the contractor and the rest to build the LV. So every before we build the LV, we need to get the permission, get the advice from the consult engineer, because they are responsibility to the site. Okay, so the current so there is so that is the reality. Okay, so every building need to do the preventive maintenance for their relay, to ensuring that the relay can work well, can trip for can trip if there is leakage at the earth, right? So I think that's all for me. Thank you.